Okay, there's a few problems in chapter 10a that you find every now and again, and it's to work out the relative molecular mass of the whole polymer, or they might phrase it as the molar mass. So basically the weight of the polymer. So I'm going to do this video for condensation polymerization, and I'll do another one later on for addition reactions. So kind of a bit of simple maths. So the question might say, what is the relative molecular mass, or what is the molar mass of the polypeptide formed? So poly, and we know what we're talking about proteins for this question. If you were given your monomers and it didn't say protein here, then you need to recognize that this is glycine and this is alanine. So from the abbreviations, that these are the two amino acids. So what's the size if we have 10 repeats of this combination? So we know we put monomers together, so we want to know the size of this polypeptide, this polymer, and every time you put them together, it's going to lose mass as water. If you've got 4 monomers, however many monomers you've got, you're going to lose one less because you have one less peptide bond. So on the very end of this monomer, you won't have a bond, obviously, so that's why there's always one less. So we need to work out how many we've got. We've got 10 repeats of this, so this could be glycine and alanine over 10 times over. So you'll have 10 repeats of 2 amino acids, which means you've got 20 amino acids altogether. And if you've got 20 amino acids altogether, then you'll have 19 water molecules lost. So we just need to look up your data booklet and find your glycine and find your alanine, and then count how many carbons, so what's the relative molecular mass of this and this. So you've got 2 carbons, 2, 4, 5 hydrogens. Don't forget this little nitrogen here, and then the 2 oxygens. Okay. So we look it up in your data booklet. So you've got 2 lots of 12, relative atomic mass of carbon, hydrogen, nitrogen and oxygen, and the size of one of those is 75 relative molecular mass, and the other one is 89. So count them up, make sure that you're okay with it. And then I haven't made a mistake, because I just made this question up. 2, 3, 4, 6, 7, yep, 14, and yep, so it looks alright. So if we had this repeated, we'd have 10 of these and 10 of these. So altogether we can work out how long our whole polypeptide is, and then we'd have to take away the 19 water molecules. So we need to know how big a water molecule. It's good to kind of have this in the back of your head, that water molecules are a size of 18. So you don't have to work it out all the time, 16 plus 2. So we need the mass of all the amino acids minus the mass of the 19 water molecules that are left. And that's our polypeptide. Sorry, I thought I'd just better tack on the example question on for you to practice. Pause it here, have a go at this, and I'm going to give you the answer now. Let's press the thing now. Okay, so condensation reaction involving 200 glucose molecules results in a polysaccharide. So we've got 200 monomers, then we're going to have 199 water molecules. So it's good to know how big a glucose is, rather than having to work it out all the time. So 6 times 12, 12 times 1, and 6 times 16. You add them all up, and a glucose is 180. It's a nice number to kind of remember. So we've got 200 glucose molecules, and then when they got together, they lost 199 water molecules.